All right, I get it. G1 particle, you said, was gravity, was light, and was like electricity. And the last time we talked, you said gravity was a steady stream, like turning on your shower with no massage on. It's just a steady stream, or like a blowing wind. And light is when you turn on the shower massage, and it comes at you like that, and that's a frequency, meaning it's hitting you in a constant frequency, and that goes in your eye and causes you colors and all that. So they're like waves of bombers coming at you, right? Here's a wave 10 of them, and here's 10 more of them, and they're all spaced apart in this way, and that becomes blue light. But now we've got electricity in G1, and one of the things Dr. Unserker talked about to us a little while back was simplicity. It seems like the G1 particle certainly simplifies the heck out of electrical circuits. And you're an electrical engineer. Can you tell us about that? I mean, that's pretty fascinating, no?
Well, yeah, it is. It's what's really fascinating is to see the particle model explain things in a different way, physically, for which we didn't have any real physical explanation. For example, the thing that powers an electrical circuit is a battery. And what I was told over and over again was that you have an electromotive force. Whatever that is, EMF, oh, well, of course people say, well, that's the voltage in the battery, the voltage. It's the voltage that pushes the electron around the circuit so that the electron can hop from hole to hole to hole. If circuits work as fast as they work, and they're hopping from hole to hole to hole, doesn't seem like that model fits our particle model at all. First of all, we don't know what the electromagnetic force is, and the image of these things hopping around just is really silly. Well, the particle model says it differently. The particle model doesn't start with an electromotive force, which I don't know what that is. It starts with the G1 particle flowing out of the negative terminal of the battery, already moving at speed c. Gravity moves at c, light moves at speed c, the electron moves at speed c, and we call it all one, the same gravity G1 particle, and it becomes the actual organized flow that causes the circuit to work. It's not the electromotive force, it's this heavy stream, this very high stream of G1 particles moving through the circuit, either gaining G1s or losing G1s. The battery gains G1, it adds G1s to the stream. And resistors, the passive networks, they lose G1s, and so when a component adds G1s, you have a voltage gain in a traditional sense, and when you lose G1s, you have a voltage loss. But the actual mechanism is just the sheer magnitude of those things flowing out the negative side, through all the components in the circuit, back to the positive side of the battery. And the battery's obligation, by the way, is a regulator. It's a regulator that guarantees that it puts out enough G1s such that the number lost in the rest of the circuit matches the gain of the battery. That's when the circuit stabilizes in what we call its DC state. So it's totally different. It's simple. It's moving at c like light and gravity. I don't have to have some fictitious electromotive force doing it because it's already moving at c. And why are they moving at c? An extra piece of information inside the battery. These G1 particles come from the atoms and they're orbiting around the nucleus, probably at or around speed c. and when they're released, they're moving at c in the first place, and they continue to move at c. If the electron and the photon and the graviton are all moving at speed c,
Photon.
photon,
Yeah, you said photon.
oh, I'm sorry, photon, then one could conclude that it's the same particle with no charge. And what's more interesting, as you get into other areas of magnetics, electrostatics, and even chemistry, these three particles still work about the same way. We haven't covered that yet, but it still seems to work.